Hi everyone, in our today's session we are going to speak about key nearest neighbors KNN algorithm for a classification problem. So as you know, the KNN is a type of supervised learning algorithm, a simple yet powerful method for both classification and a regression problem. So today we are going to check KNN for a classification problem. KNN works by finding the distance between a new data point, which means the test data set and all the examples in the data training data set, selecting the specific number of nearest examples, and voting for the most frequent class level among them. The key parameter in the KNN is the key, which means nearest examples, determines how many neighborhoods influence the classification. To better understand that one, let's go to in our example dataset and calculate KNN step by step. Let's consider a small dataset here for us which consists of 5 input dataset for us for train and 1 NIF data point. And the training dataset consists of 2 features, weight and height, and we do have our target class, in other words our labels, as a dog or cat. For instance, in our training dataset, the first data point has been assigned as a dog, the second one as a dog, and third one as a cat and dog, right? And this is our training dataset that we need to work on it in order to calculate KNN. Once a new data point comes in with the same attributes, in other words features, weight and height, and in our goal, our aim is to define the labels for this new data point. So we need to find out the labels. So we are going to find with KNN, is it a dog or is it a cat, right, for us? And we are going to calculate this example step by step with KNN, right? And the first step that you need to do it, you need to calculate the distance between the new data point and all the data point in training data sets. This distance can be calculated in different ways. So it can be Manhattan distance, it can be Minkowski distance, either can be Jaggard distance. So in our case, we are going to calculate distance based on Euclidean distance. And this is our formula how we are going to calculate the distance. For example, if we want to calculate the distance between the new data point and the first data point in the training data set, so we are going to make 10, which is the height of the new data point, minus 15. So it should be 15, sorry for that one. Square, and 19 minus 25 square, and this is going to be our distance from new data point to the first data point in our trained data set. Let's do this calculation let's do the calculation to calculate distance between the new data point and the last data point in the training data set. So our distance is going to be index 5 and index 4. So what we need to do it here, so SM goes here, so based on our formula, this P1, new data point 10, minus 17 square plus 19 minus 26. Once you did this calculation, you will find out that the distance between the new data point to the last data point in training data set as a 9.899. So you can do this all the calculation for the other data points as well. The formula is quite easy, as can be seen here. You can find out in the internet as well. So once you calculated distance between new data point to all the data point in the training data set, Then you are going to the second step to order the distance table by ascending order by the distance that we calculated. Once you order this table in ascending order by distance, you are going to have a new table here. The main idea here is because we are considering that the new data points should be closest to the training data set, right? And in that case, that or the closest one, it's index 4, right? It's 1.41. The second one is index 3, 3.61. And the farthest one, farthest data point in training data set is the index 1, it's been 19.8049. So we sorted by distance, right? And the next step is we need to choose the key for us. So the key here is key nearest neighbors. And in our case, we set up key as a tree. In other words, we are saying that we are considering the first closest 3 data point in order to assign the new data set as a dog or a cat. When you set up the key as a tree, so you are considering the first 3 closest data point and you are disregarding the all other data points, right? You can see that here, if this is our new table, data set table, that for key tree. As a next step, you need to have label counts. I mean, how many times the cat has been appeared and how many times the dog has been appeared with setting up key as a tree. So in that case, as you can see, the cat has been appeared 2 times in our data set. The dog has been appeared only 1 time. As a next step, based on the majority vote, you are going to assign the new data point either as a cat or dog. As you can see that as the cat has been appeared more than the dogs, so we are going to assign the cat as a new data, as a label for our new data set. So that's all about KNN, how does it work for classification program. In our next session, we are going to work with KNN for a regression program.